Welcome back to the session on central difference interpolation formulae. In the previous session, we discussed one of the 5 central difference interpolation formulae, namely Gauss forward interpolation formula. Here, we shall discuss another central difference interpolation formula, namely Gauss backward interpolation formula. If y naught, y1, y2 etc. and y minus 1, y minus 2 etc. are the values of a function y equal to f of x corresponding to the equidistant values of x, namely x naught, x1, x2 etc. and y x minus 1, x minus 2 etc. with interval of spacing h, then we have y is equal to y of x, that is equal to y naught plus u c1 into delta y minus 1 plus u plus 1 c 2 into delta square y minus 1 plus u plus 1 c 3 into delta cube y minus 2 plus u plus 2 c 4 into delta raised to 4 y minus 2 plus u plus 2 c 5 into delta raised to 5 y minus 3 plus etc., where u is equal to x minus x naught divided by h. This is known as the Gauss backward interpolation formula. We can derive this formula from Newton's interpolation formula. We know that the Newton's interpolation formula y is equal to y naught plus u c1 into delta y naught plus u c2 into delta square y naught plus u c3 into delta cube y naught plus etc., where UCR is equal to u into u minus 1 into u minus 2 into etc., u minus r minus 1 divided by r factorial. Now, we have delta y naught is equal to delta of E y minus 1, because in the finite differences we defined the shift operator E f of x as f of x plus h, the forward difference operator delta f of x is equal to f of x plus h minus f of x. Therefore, we can write delta y naught is equal to y naught as E of y minus 1 and delta y naught equal to delta E y minus 1, which is equal to delta into 1 plus delta y minus 1, because from this we can write delta as E minus the identity operator, or E is equal to delta plus 1 means the identity operator. Therefore, here we can write delta E y minus 1 as delta into 1 plus delta y minus 1 which is equal to delta y minus 1 plus delta of delta y minus 1 means delta square y minus 1. That is delta y naught is equal to delta y minus 1 plus delta square y minus 1, and delta square y naught can be written as delta square of e y minus 1. Here y naught can be expressed as e y minus 1, which is equal to delta square of, here e equal to 1 plus delta of y minus 1, that is delta square y minus 1 plus delta square of delta y minus 1 means delta cube y minus 1. Similarly, delta raised to 3 y naught can be written as delta cube y minus 1 plus delta raised to 4 y minus 1, and so on. Using these values, we can write this formula, that is the Newton's forward interpolation formula, as y is equal to y naught plus UC1 into delta y naught, that is UC1 into delta y naught is delta y minus 1 plus delta square y minus 1, delta y minus 1 plus delta square of y minus 1 plus UC2 into delta square y naught is delta square y minus 1 plus delta cube y minus 1 plus UC3 into delta cube y naught is delta cube y minus 1 plus delta raised to 4 y minus 1 plus the next term is plus UC4 into delta raised to 4 y naught, which can be written as delta raised to 4 y minus 1 plus delta raised to 5 y minus 1 plus etc. That is, this is equal to y naught plus UC1 into delta y minus 1 plus UC1 into delta square y minus 1 plus UC2 into delta square y minus 1 plus UC2 into delta cube y minus 1 plus UC3 into delta cube y minus 1 plus UC3 into delta raised to 4 y minus 1 plus UC4 into delta raised to 4 y minus 1 plus UC4 into delta raised to 5 y minus 1 plus etc. That is, y is equal to y naught plus UC1 delta y minus 1 plus, here there are two terms containing delta square y minus 1. Combining these two terms, we can write UC1 plus UC2 into delta square y minus 1, UC1 into UC1 plus UC2 into delta square y minus 1 plus, here there are two terms containing delta cube y minus 1. Combining these two terms, we can write UC2 plus UC3 into delta cube y minus 1 plus, here there are two terms containing delta raised to 4 y minus 1. Combining these two terms, we can write UC3 plus UC4 into delta raised to 4 y minus 1 plus etc., which is equal to y naught plus UC1 into delta y minus 1 plus, here UC1 plus UC2 means U plus 1 C2. We can write UC1 plus UC2 as UC1 means U plus UC2 is U into U minus 1 divided by 1 into 2, that is equal to U is common, U into 1 plus U minus 1 divided by 1 into 2, that is U into, here 2 into 1 is 2 plus U minus 1 divided by 2, that is U into, here U plus 2 minus 1 means 2 minus 1 is 1, that is U plus 1 divided by 2 means 1 into 2. That is this is equal to, we can write this as U plus 1 C2, that is UC1 plus UC2 means U plus 1 C2. Therefore, we can write here U plus 1 C2 into delta square y minus 1 plus, similarly we can write UC2 plus UC3 means U plus 1 C3 into delta cube y minus 1 plus, this sum can be expressed as U plus 1 C4 into delta raised to 4 y minus 1 plus etc., that is equal to y naught plus UC1 into delta y minus 1 plus U plus 1 C2 into delta square y minus 1 plus U plus 1 C3 into delta cube y minus 1. Here delta cube y minus 1 can be written as, this delta cube y minus 1 can be written as delta cube y minus 2 plus delta raised to 4 y minus 2 plus U plus 1 C4 into delta raised to 4 y minus 1 can be written as delta raised to 4 y minus 2 plus delta raised to 5 y minus 2 plus etc., because here delta cube y minus 1 means delta cube of y minus 1 can be written as E of y minus 2. E means the shifting operator, shift operator. Therefore, this is equal to delta cube. Here E can be written as delta plus 1 or 1 plus delta of y minus 2, that is delta cube y minus 2 plus delta cube of delta means delta raised to 4 y minus 2. that is delta cube y minus 1 is equal to delta cube y minus 2 plus delta raised to 4 y minus 2. Similarly, delta raised to 4 y minus 1 can be written like this. Therefore, we can write y as y equal to, this is equal to y naught plus u c 1 into delta y minus 1 plus u plus 1 c 2 into delta square y minus 1 plus u plus 1 c 3 into delta cube y minus 2 plus u plus 1 c 3 into delta raised to 4 y minus 2. Here a term containing delta raised to 4 y minus 2. Combining these two terms, we can write u plus 1 c 3 plus u plus 1 c 4 into delta raised to 4 y minus 2 plus etc. This is equal to y naught plus u c 1 into delta y minus 1 plus u plus 1 c 2 into delta square y minus 1 plus u plus 1 c 3 into delta cube y minus 2 plus this sum can be written as u plus 2 c 4. U plus 1 c 3 plus u plus 1 c 4 means u plus 2 c 4 into delta raised to 4 y minus 2 plus etc. Proceeding like this and grouping the terms, we have y is equal to, y means y of x which is equal to y naught plus u c 1 into delta y minus 1 plus u plus 1 c 2 into delta square y minus 1 plus u plus 1 c 3 into delta cube y minus 2. These are u plus 1 c 2, here u plus 1 c 3 plus u plus 2 c 4 into delta raised to 4 y minus 2 plus u plus 2 c 5, next term is u plus 2 c 5 into delta raised to 5 y minus 3 plus etc. This is known as the Gauss backward interpolation formula. Now, let us observe the corresponding difference table. The values of x are x naught, x minus 1, x minus 2 and x minus 3. Here x 1, x 2 and x 3. The corresponding y values are y minus 3, y minus 2, y minus 1, y naught, y 1, y 2 and y 3. The first differences are here delta y minus 3, this is y minus 1 minus y minus 2 is delta y minus 2, y naught minus y minus 1 means delta y minus 1, here delta y naught, next is delta y 1, delta y 2. The second order differences are delta square y, which are delta square y minus 3, delta square y minus 2, delta square y minus 1, delta square y naught, delta square y1. The third order differences are delta cube y minus 3, delta cube y minus 2, delta cube y minus 1, delta cube y naught. The fourth order differences are delta raised to 4y, which are delta raised to 4 y minus 3, delta raised to 4 y minus 2, and delta raised to 4 y minus 1. The fifth order differences are delta raised to 5 y minus 3, delta raised to 5 y minus 2, and the sixth order difference is delta raised to 6 y minus 3. Here 7 values are given. Therefore, we have sixth order difference up to sixth order differences. From this difference table, we can observe that if we draw a central line, this is the central line, the even order differences delta square y minus 1, delta raised to 4 y minus 2, etc., which are used in the Gauss backward interpolation formula lying on this central line, and the odd differences which are used in the formula, that are delta y minus 1, delta cube y minus 2, delta raised to 5 y minus 3, etc., all are lying a line above this central line, and in order to obtain better accuracy, we can choose x naught such that the value of u, that is u is equal to x minus x naught divided by h, lies between minus 1 and 0. Then we can obtain a better accuracy in our interpolating value while we use this backward interpolation formula. With this, let me conclude this session. Thank you for watching this session. Have a nice day.